Bismillahirrahmanirrahim. I'm going to discuss the very basic concepts of murmurs, and it may be helpful for especially for the undergraduate students. So if we know the exact pathway of blood flow through the heart, it becomes very easy to understand the murmurs. So suppose this is a heart and I'm making a very simple diagram. This is left atrium, this is right atrium, this is right ventricle, and this is left ventricle. And we know that blood enters into left ventricle through a valve that is called mitral valve. Similarly, blood enters into right ventricle through tricuspid valve. And blood leaves from left ventricle through a valve that is called aortic valve. Suppose this is an aorta, although its direction is in the opposite side, but just to simplify the diagram, I am drawing it here. Suppose this is aorta and blood is leaving the left ventricle through the aortic valve into aorta and through the pulmonic valve into pulmonary artery. Suppose this is pulmonary artery. So, four valves we have discussed: a mitral valve, aortic valve, tricuspid valve, and pulmonic valve. Now, if I make a more simple diagram and I just separate it just for understanding. Suppose this is right ventricle and this is tricuspid valve and this is pulmonic valve. And this is the left side of the heart, and suppose this is mitral valve and this is aortic valve and this is left ventricle. So in both sides basically there are three main chambers: an atrium, a ventricle, and an artery. Artery here is the aorta, and here on the right side is the pulmonary artery. So actually both these chambers, their subchambers, they correspond to each other, especially when talking about the murmurs. Both we have atria, we have ventricle, and we have an artery. And just to understand, if I synchronize it and make it more simple and make a single diagram here like this. Suppose these are three chambers: 1, 2, and 3. The chamber number 1 is atrium, the chamber number 2 is ventricle, and chamber number 3 is artery. So first there is mitral or tricuspid valve, and second there is aortic valve. And we all know the direction of blood flow is this. Now, to understand it in simple words, let me just ignore the right side and let me just consider that this is the left side, and I'll be discussing the left side only, because if we understand the murmurs and their timings according to the left side, it will be easier to understand the right side as well, because tricuspid murmurs and mitral murmurs are almost same. Similarly, the aortic murmurs and pulmonic murmurs are same as far as their mechanism and their timing is concerned. So suppose this is a mitral valve and blood is flowing from the atrium into the ventricle, and we all know that blood flows into the ventricle in diastole. So when there is obstruction here or there is narrowness here, there will be problem with the flow of the blood and it will become turbulent. There is one principle of murmurs that everyone must understand and everyone must know, that a murmur is produced whenever there is a turbulence to the flow of the blood, whether it's in the normal pathway, and in the normal pathway it's usually due to stenosis of the valves, or it's in the opposite side or in the opposite direction to the normal pathway. So when this turbulence is in the normal pathway, it's due to mostly the stenosis of the murmurs, and whenever the turbulence is created in the opposite direction of the normal pathway, it's usually due to the regurgitation of the blood flow. So suppose blood flow is entering into the left ventricle like this, and we all know that blood enters into the blood enters into the ventricles in diastole, right? So if this valve is narrowed or stenosed, a murmur will be produced in diastole because of the turbulence of blood. So if this valve is mitral, we can conclude here that mitral stenosis will lead to a diastolic murmur. And similarly, we know that blood enters into aorta from the ventricle during systole, and suppose there is a narrowness here in the aortic valve, the turbulence will be created during systole. So the aortic stenosis murmur will be a systolic murmur. So up till now, I hope things are clear. Now I am drawing this picture again to explain the regurgitant murmurs. Suppose again we have these two valves. This is left atrium, this is left ventricle, and this is aorta. Suppose this valve, it has got some leakage. As this valve is leak due to any reason, I'm not going into details. Suppose this valve is leaking due to any reason. In systole, the blood ideally should entering only into the aorta, but as this valve is leaked and it's not closed properly, in systole this will also enter into the left atrium, but as it's against the normal pathway, it will be associated with turbulence of the blood and eventually creating a murmur. And as this regurgitation is happening at the mitral level or across the mitral valve, this will be called mitral regurgitation murmur. And definitely, as we know the mechanism, it's happening in systole, so it will be a systolic murmur. Similarly, in case of this aortic valve, we know that the normal flow of the blood is in this direction. Just suppose that this valve is leaking. So ideally it should be closed during diastole. It should be opened only in systole to allow the blood flow from the left ventricle into the aorta. But if this valve is leaking or is incompetent, the blood flow will be in the reverse direction as well in the diastole. So as the turbulence is produced here, it will be called aortic regurgitation murmur. And as this regurgitation takes place in diastole, so we can conclude that aortic regurgitation murmur occurs in diastole, and this is a diastolic murmur. So now the things are very clear. The mitral stenosis murmur and aortic regurgitation murmur, both of these are diastolic murmurs. And similarly, the mitral regurgitation murmur and aortic stenosis murmur, both of these are systolic murmurs. And as we know, as we have already discussed, that mitral valve is at the same position as compared to the tricuspid valve. So all the murmurs happening at the mitral valve, they will be same in the tricuspid valve as well. For example, in tricuspid stenosis, it will be a diastolic murmur, and in case of tricuspid regurgitation, it will be a systolic murmur. Similarly, aortic valve and pulmonary valve, they both correspond the same position according to flow of the blood. So we have seen that aortic stenosis murmur is a systolic murmur. Similarly, the pulmonic stenosis murmur will also be a systolic murmur. Similarly, aortic regurgitation murmur is a diastolic murmur. Similarly, a pulmonic regurgitation murmur will also be a diastolic murmur. So I've tried to make the things clear so that it's easier to understand and remember, and I hope it clears the basic concepts of murmurs. Thank you very much.